Okay, welcome back to the data management practices track. I'm still, or again, Aldis Karlauskis, one of the Techies of Baltics founders. If you're interested more into community stuff, feel free to check that out. Then, of course, greetings from our knowledge partner, Pact. The more you comment on things, react on things, ask questions, and so on, the highest chances you get to receive the free ebooks at the end. So the most active participants will be highly gifted, appreciated. And then now we got ha. I'll try once again. Ha. You will need to help me with that. You correct me later on, but I'll try it. Javier,
Yes,
Javier,
that's perfect. Yeah.
and there's Thomas. That's a little bit easier for me from the company Quicks, and they have prepared something, a big surprise. I feel. And then everyone will need to bring out their devices and help them to make this work, is my guess. But definitely, they will show you, they will explain to you what needs to be done. And then I hope that your demo will break. That's the
No,
purpose.
I don't.
So please, Javier, feel free to take over.
Great, thank you, Liz. So I'm gonna share my screen. You should be seeing that. So welcome. Hi, everyone. This is the most dangerous demo ever. Or in other words, we are going to see today how to build a Python service that will analyze sentiment on messages in real time. I am Javier, just like that, Javier. I'm Javier Blanco, Senior Data Scientist at Quakes. I previously worked as a Senior Data Scientist at Orange in Spain. And before that, I worked for Jaguar Land Rover in the UK. And I have with me Thomas today.
Hello, I'm CTO and co-founder at Quicks, and I spent my whole career with the streaming, although it wasn't called streaming at the beginning, and working with sensor and telemetry data all the time. My last job was in McLaren. I was introducing Kafka and streaming to F1 racing, connecting cars on the track to cloud, so then people in factory can use it to build real-time decision insights. Um, Back to you, Javi.
Great. So as we have just said, we are going to be building a demo here in our step 6. And it is quite dangerous. We are reasonably afraid things could go wrong as we will build stuff in real time, live with you, using your messages. But before that, before going into that, we want to do some concepts introduction. So for those of you in the audience that don't know about streaming, we're going to start introducing what streaming is and what it is versus bots. Then we will talk about our goal today, again, building a Python service that will analyze the sentiment on messages in real time. We will tell you how it's going to be our approach to build this. And then we will talk about how streaming can be used for MLOps. That is, how can we use streaming for robust and fast ML model development versus more traditional REST APIs. Finally, we will talk briefly about who we are, and then we will be ready to start the demo. Let's start then. And let's start, as promised, with a comparison of streaming versus batch. So these are two ways to process data. And on the one hand, we have batch. This is quite traditional. You collect a set of data, maybe in a database, and then you load that data into your IDE or into whatever analytics system where you are going to process the data. On the other hand, we have streaming. With streaming, you process the data piece by piece as it is generated. So you do it close real time. Another way to put this is, let's think of data flowing as that river that you see over there. In batch, we will have this bucket gathering some water, and when it's full, we put that bucket into another thing, a lake where we process our data. Again, in streaming, we do stuff piece by piece. So it is like building a pipeline, a pipe between our data flowing and the process data, since we are going to be processing in the pipe piece by piece. Just another way to show this. Imagine we want to do an aggregation on some data. Here we have our new data. With the traditional batch approach, first we load that data into a database, and then we consume the data from that. We load that data from the database into whatever processing system to aggregate it or do whatever transformation. In streaming, though, as we get every piece of data, we can perform the processing on it straight in one operation. So you see here the advantages. We are working on it in real time, and we are saving ourselves lots of resources by not storing unnecessary data. Good. Now that we have this introduction of what streaming is versus batch, let me tell you how this will work in a company with an example. I told you earlier that I used to work at a telecom company, and the data infrastructure there follow a batch approach. So during the day, the different types of information will accumulate in the different systems. So calls data will accumulate in this database. Then there will be this other one for internet data or SMS data. Then at night, the data engineering team had created some jobs to load that data from those specific systems into a big data lake where we had the historic static data, and it was a traditional data lake built in layers. A first one for loading, then there will be some merging, and then processing two, and as a data scientist, my machine learning model will live in one of those processing layers. For instance, a machine learning model to predict the client churn. And as you can see, this introduces some delay. My machine learning model will be running at night with data from all over that day, and its score will be available for the whole next day. As you see, we are introducing here some delay between the score that produces the model and the data as it gets produced. How will this be if this company was using an streaming approach? Well, we will have topics, one per system, and we will have another topic for processing layers. So as we get new information, for instance, as some of our customers receives a new call from the competence, we could run the model with that new data to update the churn score. So we react in real time. We process the data in real time. I have just said the word topic. So for the last section of this introduction, streaming versus batch, I'm going to tell you what the basic elements are in a streaming architecture. First, we have topics, and topics are the pipes where the data is streamed. Then, on the one hand, there is a party publishing the data into the topic. The data stays there into the topic for a while, available for consumption, and then it disappears. So it is not a database that is persisting all data there. Then, on the other hand, there can be one or more parties at the other side subscribing to the data, listening to the data that becomes available in the topic. Another great characteristic of streaming systems is that they are asynchronous. So it doesn't really matter how many producers or subscribers they are. It doesn't really matter at which rate the producers are writing or the consumers listening. It's going to work. Great. I hope this works as an introduction for what streaming is. And now I'm going to pass back the presentation for Tomas.
Thank you, Javi. So I'm gonna share my screen, and Javi, if You can see, can you please just...
Yes, I see your screen.
Cool. All right. So what is the goal of today? We want to do it slightly differently. We want to use streaming, as Javi just described. I want to build a sentiment analysis of a chat in a simple chat application where you have different rooms where you can join and have a discussion. And our approach, gonna use Python because that's where the ML really being created and is the ecosystem where ML libraries are present. And we're gonna rely on Kafka and Kubernetes. We're not gonna use Flink or Spark streaming. We're gonna rely on those two technologies to build resilient and scalable solution. We're gonna bring microservices into a data problem. So we're gonna build different microservices around the broker, and we're gonna connect them via topics, as Javi showed you. And Kafka and Kubernetes will give us, when we use them in a harmony, the resiliency and scalability at the same time. That might sound a bit complex, but bear with me. I will show you that we hopefully make it easy to use. Now, before we go to the actual building and creating application, let's talk about streaming for ML deployment and how they're different to our original older way of deploying ML models using REST API. So before we go there, just a bit of a synchronization between us. Obviously, normally in ML application, you would probably do model training. We're not going to talk about online training today, etc. But the basic idea here is that you have a history data, you label them, you train the model, and then you serialize it to pickle file, which you then load in Python to call it. And then when you have this artifact, you create a microservice with REST API, and that API exports an endpoint where you can call API request with input variables. You deserialize this request, you call this pickle file in application, and you return response. In a response, the output of this call. Now, this has some inherited problems. First of all, API calls introduce delay and CPU overhead. So if you have a lots of calls, you would just basically getting a delay between request and response, but also you're gonna pay for CPU in underlying resources. But also, what if we have more and more data in our pipeline? Well, what's gonna happen basically is that our microservice gonna get slower and slower. And as it gets slower, at one point, it will reach to the limit of timeout for our client. And at that point, clients will get timeout. And that's not really great because we have a downtime in our system. Some of the clients have their application is not working. They don't get sentiment of their chat room. Now, this could be solved by scaling your microservices into multiple replicas, but this is always just a race between what is going to be the spike at any moment and how many resources I have to provision to get this in a reasonable fashion under the timeout limit. Now, streaming, on the other hand, works slightly differently. So in a streaming architecture, we would send input variables, aka request, into input topic, and then we're gonna subscribe to that topic in our application, where we're gonna load it into memory and call our pickle file, and then we will publish the result of that call into output topic. Now, why this is a good idea? Well, first of all, it's scaling really well because we have in each topic a couple of subtopics, we call them partitions, where we redistribute our requests, and then a same portion of small topics partitions that get assigned to different replicas to our processing deployment. Which that means that if you imagine, let's say we have a 9 request and we have 3 partitions, or maybe let's say we have 27 requests and 9 partitions, each partitions get 3 requests on average, and that each processing gets third of the partitions. So in our case, 3 partitions. This is not just scalable solution, but also it is a resilient solution. So if we have, for example, a problem in our code and one of the instances of our processing pipeline get restarted or just simply crash, others will take the load and continue in processing. Also, the input and output topic, because it has many partitions, those get spread in a cluster to the different nodes. So we can horizontally scale this pretty much forever. And then we also set replica for each partition to be sent twice or 3 times. So if one of the nodes in a Kafka cluster get hardware failure, the others would take the load. So hopefully this makes sense and kind of was it clear enough? If it wasn't, please shout on a Q&A and let me know. I would just check the Q&A. There's no question, but if you have any question, please put it there. Before we go to demo, I just want to explain last bit here that is very important, because this is kind of a queue in each topic. If you have a spike in messages, the worst thing that can happen is that we get a delay in processing. That's why this is more resilient than ML API deployment, because it's more and more load, a bigger amount of time for response, but it will not get timeouted because it is asynchronous processing. So before we jump to the demo, a bit about Quicks. So we were building this in Formula One, and that was quite demanding environment. Each car were sending roughly 30 million values per minute. So we were kind of forced to use this approach because any database-driven architecture would basically trip over. Database was always the bottleneck and couldn't handle this amount of ingest and processing at the same time. So we basically built a streaming first architecture around it, but we found out that it's actually a bit of a complex job in terms of infrastructure and gluing together. So we built a Quicks platform that helped this to give you this basically in a day one and make this whole the whole thing a bit easier. So if we jump to the actual architecture, what we're gonna build here. So I would like to ask you to get your QR codes on your phones ready, because I'm gonna need a small help from your side. So I'm gonna go to Quicks, and here I have a simple front-end application running in my workspace, where if I enter room demo room as Tomas, if you scan this QR code, you can join me in this room and have a chat with me. So hi all. I'm gonna wait because I was told that there's up to 15 seconds delay. So I understand that you're not seeing this yet. Cool. So I see that Javier
Yeah, I
joined.
have just joined.
There's a question in the chat, maybe in the meantime. What NLP model did you use for the inference bird?
We will go into that in a second. But yeah, we are using here some transformers from Hugging Face. We will show you how we did that, what Hugging Face is for those who don't know it. Our focus today, though, is not the NLP training, but the machine learning model artifact being put into production with a robust and fast system, just as Thomas explained. So we have some people joining there, but please go on and join us. Everyone in the audience, I see 90 people in the audience, so feel free to join us.
We can't break it if you don't join. Please join.
Cool. Another one. Yeah. So I hope. Yeah. Cool. So we have some people. Amazing. So basically, what you're just looking right now is being a message, sorry, a topic with messages where we're pushing data from our phones, and now we want to build this microservice in Python that's going to analyze these messages and output the sentiment into the chat. So if we manage to do this, we will get these names colored based on sentiment. And here on top right corner, we will have an average sentiment over the time. So let's go back to our Quix workspace, and we're gonna build a transformation that's gonna do this exactly. Here we have some no-code examples and no-code processing modules, but we're not gonna use them. We're gonna build this from scratch, so we have some fun. But there's a sentiment analysis in a library, so you don't have to actually code it. So here, this is a template which will do a pub and sub for us, connect topics, Kafka, and give us a Docker image to Kubernetes deployments. So basically, it's fully wired up repository in Python that's going to work out of box. Here, I'm just going to answer some questions. First is the name. So this is going to be sentiment analysis. And where I want to subscribe, what input from my microservice? Well, that's going to be messages. And I want to output it to sentiment. So this is exactly what we were discussing here in our diagram. The input here is messages, where we're sending data from front-end application. And we're going to build this middle part right now, and then output the results to output topic. So I will save it as a project. And this will give me this nice Python function where I can react for events and call the ML model. But before I do that, I'm just going to basically here print it to console to see if I'm connected to the pipeline. You can clone it using Git and basically use your favorite IDE. I'm not going to do that. I'm just going to use our web browser IDE, which is connected to Kubernetes-based development environment that is spin up for you when you open this project here. So if I run this, yeah, so I see that you sending messages. That's pretty cool.
So Thomas, if I right now, that IDE is listening to the topic, right? So if I say, hi, Thomas, from Spain, and I click send, that should appear there in the console. There you are.
Cool. Yeah, it's in a console. Cool. So that's working. So let's stop this and let's actually build the ML model. So first of all, we need to add pip package which is going to give us ML artifact. We're going to use transformers library, which is full of very interesting models. So we don't have to train it here on the call. That obviously will be out of the time we have. But here you can see in the console that is now being downloaded from the big catalog and being installed. Then
Thomas, this is the question they were making. So these library transformers comes from Hugging Face. I recommend you have a look to Hugging Face if you want to look for both data sets and already trained machine learning model artifacts, especially in NLP and image recognition fields. So these are big deep learning models that are considered reference in the field, or databases that are considered reference in the field. They're open source, so this is what we are bringing here with this library transformer.
Thank you, Javier. So here in a main PI, as you can see, everything is wired up to work with our environment. And I'm only just going to change here the name of stream to what the front end expect. And then I'm going to load the Hugging Face model with this code here. This gives us English-based sentiment analysis, and we're going to load it into this variable, and then we're going to just pass it to our function. Just to explain what the function here is, every room in our chat room application is one stream, and one stream is then processed by one function, so we don't have to cross stream variables, etc. Cool. So then if we go to the actual function, here I'm going to import from transformers the pipeline. That's basically where the artifact is going to be stored. And here we expect that pipeline to be here. And we're just going to set it to field variable in this class. Cool. So as we already established, in this callback, we get every message coming from your phones. And now we just have to basically call this ML model in memory to get the score from the message. Now, that's going to be this couple lines of code, so 4 lines of code. What we'll be doing here is getting the score and making it -1 if it's negative and +1 is if it's positive message. And then the last bit here is just to output it to the topic. And this is where we're using Quix SDK. This is a library in Python which helps you to read and write messages from and to Kafka broker very easily. So here I can basically create a tabular data like this. So output stream, I'm going to add a timestamp. The timestamp is coming from the message from your phone, so I don't have to introduce it. And I'm going to add some tags. Basically, tags contains your name and yeah, basically your names. And then I'm going to add a column called score. This is where I'm going to send if it's positive or negative message. And I'm also going to send the actual message, which is in data value, as you see here on the top where we print it. And then I'm going to add another parameter called average sentiment. Now that is the average sentiment per whole chat room. Therefore, we're going to have to do some math here. First, we're going to introduce 2 variables. One is sum and one is count. So we can later calculate average sentiment. And here, when we get our score, you're probably already getting what I'm trying to do here. I'm just going to do a self sum plus score and self.count equal. Now, what is going to give us is this average here. Cool. And we are done. So this is what we need to do to send data back to the broker. Maybe it would be nice here to print the score as well, so we see in the console that is actually working. And
maybe print the message as well, so we see the message, the sentiment.
Yeah, that's here.
Yeah, cool.
Cool. So I'm going to try it, and we will see if it's success or not. So now you see that it's loading the actual artifact from Transformers catalog. Cool. And you can see that we got the messages and we get the number afterwards, which tells you if it's negative or positive. We see that there's a this is negative message, which was negative. Hold my beer was positive. Cool. So that's working. And in theory, if I refresh this and I say hi, So we have average sentiment here, but we don't have the colors here. Let me check what I have done wrong. Yeah, I think everything is actually how it should be.
You are missing the value sentiment, which is what is red for the coloring. So add a new value called sentiment and pass the score.
Oh, yes. So my column was actually wrong.
Oh,
Thank
yeah.
you, Javier.
No worries.
Cool. So if we go back and try high, when it's obviously start. Cool. So now you see that high is green. If I say this is ugly, this is red because it's negative. And on the right, you see that sentiments being measured, and it's going to oscillate around 0 as we have in discussion. So if you now send me some messages, it will now analyze them if they are negative or positive. So I'm going to wait a bit longer so you can give it a try, because I understand there is a delay. Oh, there's some T sending test.
Yeah, hopefully what people should be seeing is that their chats update much faster than it does their screens. They should see how streaming is working to see their updates in their chats, in their chat apps much faster than they see it in their screens.
Yeah, so I see now people joining. So the reason why this is obviously real time and you don't see any delay between the message being sent and being analyzed is because it's using Kafka, and we are not calling any database. All happening in memory. There's no API calls as well. But obviously, we have just 10, maybe 20 people in this room. So this is not really a way how to show you that this actually scales. So for that, I'm gonna join a different chat, different room. I'm gonna go to the room Bitcoin as Tomas, and you can join me here as well using this QR code. And if you do that, in a second, you will see some other people talking at scale. So if I go back to my slides, then basically I have here another pipeline, which is subscribing to Twitter API. Twitter allow us to get a stream of tweets which contain certain hashtags, and then we will convert that format into our chat messages. So they will appear in a chat as you would send them from your phones. But obviously, we have the sentiment analysis here, so we will analyze them as well and hopefully get the sentiment about tweets that we are subscribing to. And as you can imagine, I joined a Bitcoin here because a lot of people talk about Bitcoin. So here I have this microservice that's basically gonna subscribe for Bitcoin tweets. And as you can see, when it starts, it would start outputting data into the topic that's then read it by Twitter chat transformation. That transformation is converting it to format of our chat messages. So it's being deployed. for some reason it's taking quite some time. Maybe we're gonna try it again to deploy.
By the way, just answer in the chat about the specific model we are using. I've added a link to the specific model in Hugging Face Tomas is using this in this demo. If you want to have.
Yeah, so for some reason our Twitter doesn't want to start. I will give it a okay. So now hopefully this time it will work. Starting, running, amazing. So there was some glitch in the system, but this is now running and it's subscribing to tweets. And there we are. We're starting to outputting data. Yeah, so we can see 2 kilobytes per second because lots of people talk about the Bitcoin. And now we're transforming them to the chat. And here you can see all the Bitcoin tweets being streamed into this chat. And because you see immediately colors, that means that this is actually coming to that microservice and being analyzed for the sentiment. And on the right, you see that it's a bit negative tone right now in the world about Bitcoin. I think it's going down, so that's probably the reason. And if we go back to our microservice here, this is basically doing the job. Now, if I stop this for now and just show you how you would move this into production. So if I stop the Twitter as well for now and tag this as a version 1. Now we're using Git to have a version control of our code. And then with the deploy button, I'm just going to put this code into container in Kubernetes, just as like that. And pick the version 1. Now this is now building into Docker image and going to be deployed into Kubernetes. And when it's done, we have a production pipeline that's going to be resilient and scalable, as we described in this slide. So, Javi, we have, I think.
Yeah, I will leave 5 minutes for the Q&A. So if you go to the last slide, yeah, I just want to say that I really hope you have enjoyed the demo and learned about the possibilities that streaming brings you. If you did, we have a free tier account in Quick, so we encourage you to go ahead and sign up just to build your own streaming application similar to what we did today. However, what I really, really recommend you is that you sign up right now following that specific QR code that you see on the screen. And that's because our colleagues from marketing have prepared a special welcome promotion for the attendees of the conference. So if you join now using that QR, you are going to have double the amount of credits forever. And this really allows you to build any system, any streaming system, any ML deployment, anything you want with IoT, anything forever. So if you are considering streaming, sign up using the link now, because this is a great opportunity. And that's everything from us, right, Thomas? We are very happy to be here. I'm waiting for your questions if you want. Yeah, Thomas, stay in that slide, because we have this delay just for people to.
Yes. So actually, if you can read the questions, if some arrive into the Q&A, please, for me.
Yes, so far we don't have new questions. The one I had, I answered, but because we have this 10-15 seconds delay, maybe we start having them now.
Yeah, hopefully we'll get a few more questions. I'm sorry if I missed that, but what is used behind this the computing power.
So the microservice running in Kubernetes. So it's just a bunch of VMs under the hood that's being orchestrated to the Kubernetes engine. And we have built a Quix SDK library, which is a Python library to help you to build streaming pipelines using Kafka and Kubernetes together without any technology like Spark or or Flink. So yeah, that's what's under the hood. I can maybe go back to this slide. So the input topic and output topic is Kafka technology, and what is in the middle, that's Kubernetes. And it's all glued by Quix SDK library.
Maybe you could describe a little your engineering process for this.
You mean when to build a stream applications?
Yeah. This is a DevOps conference. We're interested how things
Yeah.
happen. What's the behind of the story?
Yes. So basically, in what we saw is that there's a lot of moving parts in building stream architectures and stream first um, applications, and people are actually dependent on the other teams. So data scientists asking cloud engineers to deploy their models, and because it's actually a long journey to get everything right, companies would cut corners and not actually develop the full DevOps pipeline from start to end. That's why we kind of thought, hey, if we do it once and we really spend some time on it, then people can just use it and don't have to build it from scratch in every company again. And so the way how this works is that if you go to our platform, you can build microservices with our library. And this is like a equivalent of creating new repository in your Azure DevOps style or Jenkins style or Bitbucket style SaaS. And then you can develop this code connected to the broker, which is already integrated with your code. And then you use Git to version your code and manage deployments. So every deployment against a tag in a Git. So if I click on this icon, I can see exactly what code is running in that pipeline. And at the end, you have development testing, and production workspaces where you're just deploying these microservices based on your company policies. With this, you never get misalignment of what model is running where, and you can always get back to what results and what responses were made by what version of your model.
Okay, thank you. Very interesting. There's also some comments in the chat that this was very interesting and very good demo. We're also at the end of our time. Thank you for sharing with us, and see you on the next sessions.
So thank you, everyone. And have
Thank
a
you,
nice day.
everyone. Hope you had a nice time. Thank you, Uldis. Bye.
Bye.